All right, let's get into it. We've all seen those slick, futuristic videos, right? Flying taxis zipping between skyscrapers. It looks amazing. But what's the real story behind all the hype? Now, I love the idea, I really do, but I'm also deeply skeptical that this isn't just another tech bubble, fueled by huge promises and even bigger piles of cash. And you can see why people get excited. The promise is so seductive, isn't it? This whole new era of urban air mobility that's supposed to completely change how we live in our cities. We're told it'll be clean, quiet, and super fast. You know, the ultimate fix for that soul-crushing gridlock we all hate. It's a really powerful vision.
And of course, where there's a big vision, there's big money. The market projections are just astronomical. Some analysts are throwing around numbers like $90 billion a year by 2050. Numbers that big, well, they get a lot of people, especially investors, very, very excited.
But, you know, when you look behind the glossy ads and those eye-watering forecasts, a much more complicated, much messier picture starts to emerge. So is this future really built on solid ground, or is it all just hot air? Let's peel back the curtain a bit and start by doing what you should always do. Follow the money.
So, here's the crucial question. How much does it actually cost to get this revolution off the ground? And more importantly, is all that investment based on, actual solid fundamentals?
Well, the estimates suggest a jaw-dropping $40 billion in capital is needed just to get eVTOLs to a global commercial scale. I mean, to put that in perspective, that's the kind of money it takes to develop a whole new generation of traditional airliners, like a new Boeing or Airbus jet.
And right now, the companies in this space are just hemorrhaging money. Take Joby. They're one of the front runners. They lost $144 million in just one quarter. And this cash is just being incinerated by incredibly expensive R&D, a ridiculously complex certification process, and building out all the infrastructure, all before they've flown a single paying customer.
Now, this is what I find really fascinating. You hear about these massive pre-orders, thousands of aircraft, right? Well, here's the thing. In traditional aviation, when an airline orders a plane, they put down a huge cash deposit. It's a real, financially secure order. But a lot of these eVTOL orders, they're just non-binding letters of intent. There's little to no money down, which means those huge projections are built on a house of cards. They're incredibly fragile.
Okay, so the money part is shaky. But beyond the financial hurdles, there's a much more fundamental challenge, one that's rooted in pure physics. It's the one thing that powers this whole dream, and it might just be its biggest weakness, the batteries.
And this slide just illustrates the core problem so perfectly. Even our best, most advanced lithium-ion batteries are about 40 times less energy dense than simple jet fuel. And think about this. When a normal plane flies, it burns fuel and gets lighter, which makes it more efficient. An eVTOL weighs the exact same at the end of the flight as it did at the beginning. It's carrying all that dead battery weight the entire time.
So, that huge energy gap, it creates this whole cascade of very real-world problems. It means you have severely limited range, it means long charging times, which just kills the business model of quick turnarounds. Then you've got poor performance in cold weather, and we haven't even talked about the horrifying risk of a battery fire thousands of feet in the air, or the insane operational cost of having to replace entire battery packs every few months. It's a massive, massive challenge.
And this is exactly why some of the really serious players like Honda are pivoting. They're actually developing hybrid electric systems. They're basically putting a small gas turbine on board to act as a generator. Why? To overcome these insane limitations of being battery-only, especially for more practical, longer-range missions.
Now, all of these challenges, the tech, the finances, they all lead us to the single most important question, the one that could ground this entire industry before it even gets off the ground. Are they safe?
Just think about this for a second. The head of the Federal Aviation Administration, the government body that has to certify these things as safe to fly, he used the words almost incomprehensible to describe the engineering. When the top regulator is telling you he can barely wrap his head around it, that signals a very, very long and difficult road ahead to prove these things are safe.
And this regulatory confusion just highlights the global uncertainty. Look at this. In Europe, they're holding eVTOLs to the same safety standard as a commercial airliner, a 1 in a billion chance of catastrophic failure. But in the US, the FAA is applying a much looser standard, more in line with a helicopter. So if you're a manufacturer, what do you do? Which rules do you build to? It makes designing a single aircraft for the whole world almost impossible.
And a catastrophic failure, man, it could come from anywhere. We already talked about the nightmare scenario of a battery fire. But what about a tiny software glitch in the ridiculously complex flight control systems? Or something as simple as one of the many rotors failing over a densely packed city? The risks are just enormous.
I think the answer to that is a resounding, unequivocal yes. Public perception is everything, and it's incredibly fragile. A single, high-profile accident could completely destroy public trust in this technology, and that would set the entire industry back for years, if not kill it permanently. It is the one single thing that could end the eVTOL dream overnight.
So, with all these challenges, financial, physical, regulatory, what can we realistically, honestly expect to see in the very near future? Let's talk about what's real for 2026.
First of all, forget skies full of air taxis. That's not happening. 2026 is going to be a year of critical, mostly behind-the-scenes testing. We'll probably see companies like Honda fly their first full-scale prototypes. And the FAA will launch its pilot program, which will allow some of the first real-world flights. But they're not going to be flying people. They're going to be focused on things like cargo, or maybe transporting medical organs.
So the bottom line here, the big takeaway, is that the dream of hopping in a flying taxi to get to the airport, it's still firmly in the future. 2026 is about laying the very first, very tentative bricks in what's going to be a very long and very, very expensive road.
The technology is absolutely fascinating. No one can deny that. But the financial, the physical, and the regulatory hurdles are just immense. The next few years are really going to be the ultimate test. They'll determine if this industry can actually overcome all these challenges and take flight, or if it's just a really cool, high-tech, high-altitude bubble that's waiting to pop.